at the Maker Faire. Oops, Brett went away. Okay. Hi, folks. So welcome to our 6th update. I'm going to throw out sort of the net right away. Net, everything we wanted to do that we discussed in the previous meeting, everything we wanted to do except for one thing is all done. So at this point, we're still looking pretty good to start making production parts towards the end of August. All of the machines are here, and in a couple of minutes we'll do a little walkthrough to show you the machines that we have here and what all it's going to look like. And the only thing that's holding us from being able to turn up and start cutting metal full tilt is we need to get electrical power to the machines, and that requires that the township permissions be granted, and we're still working on that. With that, let me take this. Okay, I will hold. No problem, Brett. Brett asked to hold up for a couple of minutes. That'll be just fine. Let me introduce one of the other folks that's on our team, and his name is Vladimir Nesterov. He is a mechanical engineering student at Conestoga College in Kitchener, Ontario. He's one of our Canadian brethren. Over here, hi, say hi. Hello. He's very talkative. He's been working on helping to set up production, and in fact, do you have anything to show on the lathe at all? Okay, never mind that. But maybe we can show the thing moving around and spinning and whatnot. We could probably do the same thing with our friends on the mill, right? Okay. So we'll show a couple of things, and we'll see how it goes. So let's just take our little tablet here, so you can see sort of infinite regression of things. Okay, so a little tour of Okay, so my cell phone is going too. Okay. It's probably Susan calling me, telling me that nobody can hear me. Okay. The audio on the tablet is off. Yes, that does look like it. Okay. The interesting question is, how do I get it on? Aha. Is it, well, I can hear. Can you hear me still? Beautiful. Can you guys hear me? No, we're not. Okay. So the mic on the tablet is unhappy. Okay? Microphone is unhappy. Frankly, I don't know how to do this. So, you know what I'm going to do is I'm just going to walk and show you the stuff, and then I'll talk about it when I come back to the microphone here. Does that sound reasonable, guys? Yeah, more or less? Okay. All right, so I can give you a very quick talk. Okay. So, can you folks hear me? Hi.
Yes, I can hear you.
Okay, excellent. What you saw when I said the thing number one we saw was the computer cabinet where the servers are going to go into, and you saw the server sitting right next to them, already kind of running the enterprise resource planning system where all the order management and inventory management, all that stuff's going in. Then you saw the lathe. And some smaller machinery. We now have a bandsaw for cutting up the aluminum pieces. You saw in the background a drill press being used to prepare our router table to be put together. And then you saw the big mill. So all of the machines are in the shop. The mill is in its final position. The lathe is still going to get moved into the corner. We put it here closer to where the temporary power is so we can start getting it ready for production. And so basically for the next month, we're going to be getting all of these machines up and running, and we're going to be getting initial parts production going. So we'll see how it all goes. We'd like to do another update probably, I don't know, maybe at the end of August. We're going to run out to Seattle for the 3D Printer World show for a couple of days, and then be back, and hopefully we'll start being able to make parts and make printers. That's really all there is for the update. Machines are here. Yay. Does anybody have any questions?
Well, I have a question. I think that Brett, that we are, or Ben, I'm sorry, that we placed a PO with you guys, and I just wanted to, double check and see what the progress was on that. Obviously, you guys are making progress. I just wondered, I've seen the demos on all of your other videos, and I think this update is great. I just was wondering what the schedule. So what's the duration to build one unit, I guess?
So we're not going to build one unit at a time. The way that the production is going to be organized is it's really around the major component groups of the machine. And there's really three. There are parts that are exactly the same from printer to printer regardless of size. Those are all of the parts that tie together the machine, all of the machined aluminum blocks. Then there are parts that are individual specific for each machine, which are the big extrusions that are the main sort of framework of the machine. And then the third part is the extruders themselves. Okay? The extruders themselves are the same regardless of the machine, but they're made on a separate little production line. So the parts that are all exactly the same for all machines are going to be made in batches of about 12. Because I can show you more details, but basically we have, and they're sitting right over there on the cart, we have these three double-sided vise that you can put two parts into, one front, one back, and so you can mill two parts at the same time. And we're going to put three of them next to each other. And so the process is you take a big bar of aluminum, you set the appropriate length on the bandsaw, and then you chunk the big bar into the appropriately sized hunks of aluminum. Then you take these pieces of aluminum, you load them up onto the mill, put in the CNC program, push the button, walk away, and half an hour later, or however long it takes, the batch is done, or you have to flip it, or whatever. And so what we're going to do is we're going to start building these machines in batches of 6, 12, or 18. We haven't figured out yet what the best number is, because there's a trade-off between how long each operation takes and how much variation there is in the material, so that it's more efficient in terms of time to put 2 parts per station, because then you can do 12 in one shot. But the problem with that is that if the material isn't quite square and rectangular and perpendicular, you're going to get error in the machine. So initially what we'll probably end up doing is loading up 6 sets of 6 parts in one shot and milling them. If that works out well, then we might scale it up to 12 or even 18. So non-unique parts are going to be made in these batches, and then one of the things I haven't shown is that there's going to be on the other side of the room, there's going to be the assembly area where just plain wooden tables where machines are going to be assembled. So the non-unique parts are going to go from the mill to the assembly table. And then the unique parts, which are specific to each machine's size, are going to be made on the big router table that should be done in a couple of weeks. For each particular machine that's quote-unquote released to manufacture, we're going to go and cut those parts on the router table. And so then all of these parts are going to come together in the assembly area. And extruders are going to come to it separately from the little mill. All said and done, a batch should take about 2 to 3 days of machining. And so the initial rate, and probably another day of assembly. So the initial rate's going to be somewhere between 1 and maybe 2 machines a day. We have a backlog of somewhere between 40 and 50 machines. Yours is kind of, Jonathan, yours is about 2/3 of the way through the list, if I recall correctly. There have been several other orders since your machine. So if we're able to begin production in late August, figure 25 working days in the month, because we're going to pull some weekends here. Figure 1.5 machines a day maybe to start with. And I need to go through about 40 machines. So by the end of October, we should be done with our backlog.
Okay.
There are sort of major provisos for this. Number one proviso is that we do get the permits from the township shortly to get our power work done, so we can start getting the machines spooled up. That's probably our biggest challenge right now. We do have another proviso that the router table is running a little late. We were hoping to be done with it already, but it's not done yet. So it might slow us down a little bit, but at this point we're talking slowdowns measured in small numbers of weeks or even just days, as opposed to months or anything else. So the process is clearly converging. At the moment, It's looking pretty good.
So a delivery of I guess you said you drew your backlog by October. Do you anticipate any more sales between now and then? And if so, will any of those take priority over the existing, or are you just going on a first come first serve?
First come, first serve at this point. First come, first serve. So your machine is in where it is, and nobody's going to jump in front of the queue no matter what. We've been completely we've lost sales on that, but I don't care.
Ty has a question about raw materials and lead times.
When is the raw material scheduled to arrive? Are there any lead times for items at this time? So raw materials will come in basically 3 batches. There's 3 categories of raw materials. There's essentially 2 things that are coming from China, and that's the ball screws and the motors. Those take about 3 weeks to get here. Lost audio. Okay, why did we lose audio? My mic says that we're still there. Jonathan, can you hear me? Yes? I don't know why, because both Brett and Ty report that they're okay. Can you do me a favor, grab this, just walk away a little bit and turn up the sound? Sound things down there on the bottom. And let me know, do you have sound? Okay. So it looks like it might be on your end, Jonathan. Yeah, because I can actually hear the echo from the tablet over there. Any improvements, Jonathan? No? Okay, let me go through this and I don't know. Okay, so I'll wait for a couple of minutes until Jonathan comes back. There you are. Is this better? 1, 2, 3. Hello? One, two, three. Yes. Yes. Okay. All right, so I will continue then, and you're welcome. I know, but you can look at the video later. Okay, so Kai, returning back to your question. So three parts. There's some parts that are coming from China, and that's specifically the ball screws and the NEMA 17s and the NEMA 23s. Although we're probably going to switch to a different vendor for the NEMA 23s, which is here in the U.S. So that's going to kill the lead time. Then there is a bunch of sort of raw aluminum that comes from a local metal supplier that will get here typically within a couple of days to a week from our order. So that's not an issue. I will manage as we get closer to the end of August to see how progress is made to anticipate that. Okay, great. Thanks. Thanks, Jonathan. The third part is sort of generic stuff that we get either from McMaster-Carr or Fastenal, or we might start going directly to some of the small parts manufacturer. And those are things like, you know, screws and nuts and fasteners and guide rods and, you know, threaded rod and a few other things like that. So those are just basically, walk in and get it. Excellent question about glass. So we started out by using glass from a vendor out in New England, and since that time, several vendors have approached us in terms of being able to supply materials to us. At the moment, glass gets here within about 4 days, 4 to 5 days, so that's not a big deal. By far, the longest lead time is the ball screws and the NEMA 17s and some of the bearings. Although we can get bearings from VXD pretty quickly if need be. A little more expensive, but not too bad. So we actually have something else interesting that just showed up recently that we're going to try playing with. Now, this is a sample of borosilicate glass. It's a little thinner than what we're used to. This is about 3 millimeters. We usually use 5 millimeter. It's not so much that we're going to switch to 3 millimeter. It's that this piece of glass was sandblasted with a rough grit. The idea being to try using this and to see if the plastic adheres to it, primarily because if that works well, then we won't have to pre-treat glass at all. Just put it on and it'll just work. That's a little bit of experimentation. If that works, then we'll probably switch vendors. In the meantime, the guys in New England get the glass for us in like 4 or 5 days without a problem. Yeah, so basically the ball screws is the tall pole in the tent, and we'll manage to that as much as we can. That's one of the reasons why we want an inventory management system helping us keep track of where all of the different pieces of inventory are in terms of arriving here. Then, has there been any design changes since the Kickstarter? Yes, there have. They're not major. They're all cosmetic. In fact, I'm glad you said design, because in the last several days we've been working with an artist and designer to help us make the machine a little prettier without really changing the underlying features of it, the structure or the layout or the architecture of it. So we don't have any. Oh yeah. Well, the specifics. That's actually an excellent point. Vladimir has been working on some of the on updating our model with the things that are going to change. So why don't you take over and talk about that? Sure. Can you hear me with me? No. Why don't you come over here and talk into this one?
So there have been a few small changes, such as we've been trying to tug the motors high and slow breath. We have been trying to tug the motors away. As you can see right here, these guys are currently sticking out, and they're not exactly very appealing to the eye. So we've tugged them away inside the trusses, and we've made
That's the truss.
Yeah, that's truss. And we've made I've designed a motor mount that's very easy to adjust from the outside. So if, for example, you need to tension the belt, then you can do it from the outside. You don't need to get inside the truss with any intricate tools or anything. So that's one of the major changes. We have also, we don't think that it will. No, the Z-axis actually has 2 motors that are working for it, so they're sharing the load, and chances are that they will be doing just fine. And in case of heat buildup, we can always drill speed holes in the truss to let some airflow in.
Well, the other thing is that the motor will be sitting right next to a big hunk of cold aluminum. So it'll be in contact with an aluminum plate that is thermally grounded to the chassis. So it'll wick away the heat very quickly. And as Vladimir mentioned, if need be, we can stick a fan in there and blow some air out. So that's the z-axis, right? We're going to do the same thing over here on the y-axis. See how the motor is over here? And we've had trouble with shipping, with the pulley sticking out. So we're going to do the same thing here. This motor is going to turn around 180 degrees and hide inside of an extrusion bit.
And the other small changes include essentially both of the Z-axes used to have 2 guide rods, which were found to be very heavy and unnecessary. So we have changed the design so that there's only 1 guide rod and 1 ball screw without compromising structural integrity and the stiffness of the whole mechanism. And in fact, it's actually way sturdier now because the ball screw and the guide rod are way further apart from each other. So there's less of a chance that there will be any play or any sort of backlash movement. Correct.
And the same thing will happen down here in the x-axis. Inside of there, we're going to do the same basic idea. And then there's going to be a small change in the extruder mount. Right? And see how right now the way that it connects to the machine is via this very thick aluminum plate. Right? We're going to get away from that. Instead, there will be 2 narrow slots, one here and one here, and the extruder mount will reach through that and attach to the motor block, to the inner block that way. And then also, instead of being a dumb solid hunk of aluminum, we're actually going to move the adjustment mechanism for extruder height adjustment to some knobs that are going to be right on top there. That's pretty much it. Oh, no.
Jonathan is asking about pinch points and if there will be any guards.
There is one pinch point that we are still kind of. There is one pinch point, which is right here. And I've been kind of racking my brains of what to do about that. Because the problem is that space right here, if something gets inside, then the axis moves the wrong way. It will go and it will not be, no, not the belt and the pulley, but this part right here. Like the belt and the pulley, the extrusion is going to change, is going to move, and the motor's going to turn around, and there'll be a cover on top. So that'll be all hidden. You won't see that. And the same thing here. The extrusion is going to be longer, and the motor is inside, and everything is covered. Okay. But the only thing that's kind of open is this part right here. And we're still trying to figure out what to do about that. I still haven't found an alternative that is better. What about a Bella type cover? Yes, that would certainly be something to try. I've tried designing that, and I've had problems in doing so because the vertical space between the bottom of this piece of aluminum and the top of this is very tiny. There's a couple of millimeters there at the most, not even. And so a bellows kind of mechanism has trouble fitting in there. The only thing I can think of is a set of sliding plates, sort of similar to the way a lot of CNC machines, CNC mills cover their ways. And there's a similar opening on the backside as well, by the way. I don't know. We're still thinking about that. So, was there any other changes?
Yeah, no other major changes. Just some small cosmetic things and tucking away the power supplies and putting some caps on the ends of the trusses so that the motors and the electronics aren't exposed from the sides. And like Ben said, we are working with a designer to help us make the printer look more professional while keeping the industrial look of it at the same time. We've got some ideas there as well, but they're not ready to be presented yet. They're still in the brainstorming stages. So. Okay, thanks. We can talk about these.
Yeah. No, I think that's good. I mean, there's a couple of changes going on in the extruder here that I wanted to talk about. One is that obviously we're going to clean up the connector plates back here. Another one is that this on the hot end, this heat sink area right here is changing a little bit. Instead of a single machined aluminum piece, we're going to use punched out copper plates that are stacked up here in layers like this, and then there will be if I can get it, a cover like this that's kind of like this, that's going to blow on the heat sink. We have an experimental version of it running in Canada right now. It's been running pretty much flawlessly for hours on end, and we think that's a better production configuration. So that's probably, and one of the major reasons why we want to do this is because, you know, at 225 degrees, that aluminum sink was doing just fine. But we want to be able to say that our extruders run up to 275, and for them to be able to remove heat of that magnitude quickly enough, we really wanted a much more efficient heat sink, and that's what the copper plates will give us. They're roughly 10 times the square area, the square footage of the aluminum sink, if not more than that. And so that's going to be about, you know, 5 times better, maybe 10 times better in terms of providing cooling. The airflow over it's going to be pretty good too, so that's all good. And it's working right now in prototype form really well. So that's pretty much it. At this time, do you think Marlin will be optimized by production? Yes. Either that, or we will have a different alternative. One of those two. If it comes to that, and for whatever reason the software is not ready, we're going to have a conversation, and folks will be able to make a decision whether or not they want the machine where there will be a software upgrade coming out soon, or they want to wait until the software is perfect, or the software is really good. Does the machine have LAN network, or will the connection be specifically set for USB or a COM port? At the moment, the electronics inside is the ASPIC X3 Pro. That requires USB connection. There is also an SD card port on the X3 on the ASPIC. I've never used it because it just doesn't seem to really be all that great. But if anybody's interested, we can easily provide an SD extension port so that we can bring it out to the outside of the machine, and you can plug your SD card into it and see what you can do. I'm really not happy with the way the electronics are coming together at the moment. There's just too many ugly wires in there. We really want to get a little bit more organization. Yeah, no. We really want to get a little bit more organization in there, and we're exploring a couple of different alternatives to making things look much neater and work much, much better. The interesting question is whether or not that will be ready in time for when the mechanics of the system are ready to go to production. And, you know, if I have a dozen machines sitting there on the table, I think I'm going to let the customers decide whether they want to stay with the ASPIC electronics, ASPIC-based electronics, or whether or not we have a better alternative. I think at the moment ASPIC is, I think it's workable with Marlin and all that. It's workable. It's just not as good as I know we can do. Any other questions?
Yeah. Hey, this is Brett. I've got a couple questions.
Hi, Brett. Shoot.
Hey, so you said you'd have where you were trying to get to a production unit by 3D Printer Expo. Is that going to happen?
So,
production. Let's say beta.
right. So I really want to bring a 24-inch machine to Seattle.
Okay.
Whether or not I can get a 24-inch machine that is fully working with all the doodads in it, that's an open question. That's a crapshoot. But I really want to bring a 24-inch machine out there.
Yeah, I think a 12-inch would be nice. I mean, I saw you at the Maker Faire, and you had the basically the Kickstarter machine. It wasn't really printing, so just to see something that looks production ready or almost completed, it's actually printing would be I think a big win. It's big enough. 24-inch would be great, but you know, a 12 that's functioning nicely would be also great.
Okay. Yeah, well, I think I'd like that as well.
Okay. So one thing I keep on forgetting to ask is like, how is the bed leveled?
Okay. So that's probably another part of the design that I forgot to mention. So let me show you the way it works right now. So right now the glass is held with these Delrin holders, and there's a screw that pushes it one way, and inside of it is a spring that pushes it up. What's going to happen instead is the bed, instead of being a solid hunk of aluminum, is going to be a lattice work of aluminum beams that are machined to shape and put together. And then on top of that, there will be a frame that holds the glass completely securely, not those little plastic things, but completely securely encased in a metal border. And that unit will get leveled with 2 screws on front and 1 in the middle of the back. So it'll be a 3-point adjustment, not 4. Turned out that 4 points just doesn't actually buy you anything.
Okay.
What you end up doing is the 2 screws up front, they give you a level along the x-axis, and the 1 screw in the back then gives you the level along the y-axis.
Okay, that's similar to the way my Maker gear works, so I'm familiar with that.
That ended up being a much better design. You know, we started out with 4, hoping that, you know, flexibility is important, but it turns out that it's completely not important, doesn't buy you anything.
Okay, good to know. So one thing that I'd like to see, and I think a lot of people would like to see, would be some printers actually printing some large prints.
Okay.
Like big, just like even like a webcam pointed at a printer that's just always printing 12 by 12, you know, or whatever, burial urns or whatever it turns out to be. Just like some big prints. The things that you've had are pretty small, pretty simple. It doesn't have to be very complex, but I think just seeing the printers printing is gonna help the confidence of some of the, I guess we're, you know, investors at this point. You know, I think a lot of what you guys are working on has been logistics, but you really haven't got to the point where now you know, after the logistics, then you put the printer together, then you have to deal with what comes next, and like, oh, there's going to be conflicts. You know, you're using a beta controller board, you're hacking the firmware. All of that's going to add up into, you know, into possible issues or possible solutions. And it'd be good to kind of get that stuff out of the way as early as possible. I think that Kickstarter people are kind of your beta, and you need to get those units out to these people right away. They're going to give you your feedback that are going to influence the changes that you need to make for the next round of customers. So I think the last thing I had on my list here was, so why aren't you ordering the long lead parts now? At least for the Kickstarter.
There wasn't really a huge need for it because we weren't ready to receive them. We will be making that order probably in the next week.
Okay. I mean, I think that'd be cool for the Facebook page. Just as like with the piled with NEMA motors, surrounding you or something. I think it's just, good to get all that, long lead stuff out of the way, at least for the Kickstarter people. And then, once you've established a functioning unit, you can kind of go into a larger scale.
We've been so focused on this, on building out on getting the production facility, and making the modifications to the model that we just basically put everything else aside. But that's a very sensible point. Thank you. We'll get on as quick as we can. But before we leave these questions, I want to throw out one other thing. We had another team member join us. She's not here yet. She's not here right now. She's taking her family on vacation. But her name is Sandra, and she will be our printer service kind of a person. What she's going to do is do sample prints for folks, and then just anybody who wants to have a large print, she will be sort of the printer queen. And so we'll get her, we're getting her, she's already been coming for like, about 2 weeks? Coming up to speed, and then once she comes back and towards the end of August, we're still training her a little bit on some of the CAD tools. And by end of August, she's just going to be sitting here printing, and we'll point a camera at it and have her go at it. Sandra is an art and design type person. So she needs to transition to a little bit more of a sort of engineering tool set, and then be able to just sit there and drive the printer and take care of everything that needs to be taken care of. So at that point, there'll be a lot of videos. Any other questions? Okay. You're welcome. Oh, okay, great. Thanks. That would be awesome. If you could send me some links, that would be awesome. Certainly something to look at. All right. Well, thank you very much. If there's no more questions, thank you very, very much for everyone, for joining us. Again, apologies for missing it yesterday. That darn computer cabinet really took me out of the way. Thank you so much, and we will talk to you soon. Take care. Bye-bye.